Good morning, everyone, and welcome to this lecture. We are into friction, and in this class, we should be winding up this chapter with the small discussion on static friction. Now, what do you mean by static friction? Now, remember, when I talk about friction as such, friction, as soon as I use the word friction, I told you that friction can be of two types. Yes or no? One is static friction and the other one is kinetic friction. Now, in this kinetic friction, we have already dealt with this kinetic friction, but you must remember that this kinetic friction is also of two types. This kinetic friction is also of two types. The first one is known as sliding friction. Now, this friction comes when bodies are sliding over each other, and the other one is known as the rolling friction. Sliding friction and rolling friction. Now, the sliding friction comes when bodies are sliding over each other. This rolling friction comes when bodies are rolling over each other. Now, out of these two, whatever we had done in the previous classes, we had only done one type of friction. Can you tell me which type of friction had we done in the classes that we had conducted? 3 lectures we have done. We have done kinetic friction, but out of that kinetic friction, there are two types of kinetic friction, sliding and rolling. Which friction have we done? Sliding or rolling? Which friction have we covered? Sliding or rolling? Yes? Which type of friction have we covered? Was it sliding friction or was it rolling friction? Yes?
Sliding friction.
Yes, we had covered sliding friction because this is the only friction that is in your course that has to be covered, which is the sliding friction. The green friction, which is the rolling friction, is definitely not in your course. But it's not in your course, so numerical cannot come from this. But you must understand that what is this rolling friction? Rolling friction happens when bodies are rolling over each other. One body is rolling, a tire moving, body is rolling over each other. Then you have rolling friction. Sliding friction is when bodies are sliding like this. When the bodies are sliding, then we have sliding friction. When body is rolling, we have rolling friction. Now, just for your information, which friction will be more? Is the sliding friction more or is the rolling friction more? Which friction is more, sliding or rolling? Which friction is more? So remember, sliding friction is always greater than rolling friction, and that is why to reduce friction, if you have to pull a heavy box on a rough floor, it will take a lot of effort. But if you put rollers or something which is round, some bamboo sticks or some piece of wood which is round, and you put that box on that roller and then you slide it, it is easier for you to slide that box. Why it is easier? Because now the friction is not sliding, but the friction is rolling. Rolling friction is always less than the sliding friction. Do we understand this? So that is what you need to remember, that whatever frictions we have done in kinetic friction, we have only covered the sliding part because the rolling part is not in your course. But you must remember, and I've seen questions on this, that rolling friction is always less than sliding friction. We understand this, yes or no? Everyone understand this, Central Center? Do we understand this? Chintal Tanaka, do we understand this? Okay. Chalo, that takes us to the last variety of friction, which is known as static friction. Now, what is this static friction? And when does this like static friction come into the picture? Now, whenever two bodies are moving with respect to each other, there is a relative motion between the two bodies. The type of friction is kinetic. It could be sliding, it could be rolling. Anyways, when the two bodies are not moving with respect to each other, there is no relative motion between the two. Even then, there could be a tendency of relative motion. What do I mean by tendency? The body may still want to move in one direction, but it may not be able to move because there is a friction between the body and the floor, or between two bodies, which happens when there is no relative motion between them. That friction is known as static friction. So static friction. Yes, beta?
Am I audible, sir?
Yes, beta. So static friction is the friction, you're audible now, between two bodies when there is no relative motion but there is a tendency. I mean, they may want to move. They cannot move, but they may want to move. So we call that as tendency. There is no relative motion, but there is a tendency of relative motion. There is no relative motion, but there is a tendency of relative motion. What does this static friction do? It opposes the tendency of relative motion. Static friction opposes the tendency of relative motion. What do you mean by this tendency of relative motion? So you can understand it with the help of a small example. Suppose you have an inclined plane, inclined at an angle of theta, and a body of mass m is kept. This plane is rough. It's not smooth, it is rough. But not every time you keep something on an inclined plane, not every time everything will slide down. Yes or no? I told you the angle of friction using my phone. Where is my thing? Every time you keep anything on a inclined surface, it may not just slide down. We'll use a different thing. This is a surface, this is an inclined surface. I incline it at an angle like this, and I keep this thing here. You can see it is not moving. It is still at rest. It is not moving. It is not moving, but it wants to move. See, it is not moving. You can see it is not moving. It is an incline, but still not moving. See, the incline is so high, but still it is not moving. It is not moving, but it has a tendency to move. In which direction is the tendency to move? So this is what the diagram says. It is not moving, but it has a tendency to move. This is at rest. It is not moving, but it has a tendency to move. In which direction does it want to move? In which direction does it want to move? This is not a question of physics. This is a question of common sense. In which direction does it want to move?
Downwards.
Okay, it is not moving, but it wants to move in this direction. It wants to move in this direction, but it is not moving. So there must be something that is stopping it. There must be something that must be stopping it. What is the thing that is stopping it from moving? What is that thing that is trying to stop, or stopping, not trying, it is stopping it from moving? That thing is known as That thing which is stopping it to move is what? It is not moving. There is no relative motion, but it wants to move. It cannot move. Something is stopping it. What is stopping it? What is stopping it from moving down?
Sure, sir.
Yes, beta?
Sure.
Your voice, it breaks in between. I repeat my question. It wants to move down, but it is not moving down. Something is stopping it. What is stopping it from moving down? Yes? What is stopping the body from going down? What is stopping the body from moving down? It's written here on the whiteboard. What is?
Static friction.
Yes, it is not moving down. Someone is stopping it, and that something which is stopping it is static friction. So static friction comes into the picture when there is no relative motion, but there is a tendency of relative motion. Let me give you another example. Again, this is now a horizontal floor. Again, I keep a body of mass M. Again, you must understand that the surface is rough. I apply a force here, F. It's a very heavy object, and I apply a small force. If I apply a small force, but it is still remaining at rest, it is not moving. It is not moving, as you can see, but it wants to move. Where does it want to move? In which direction does it want to move? This body is not moving, as you can see, but it wants to move. In which direction does it want to move?
Right.
It wants to move in this direction because there is a force acting in this direction. It is trying to move it in that direction, but it is not moving. It is at rest. Something is stopping it. What is that thing which is stopping it?
Static friction.
That is again your static friction. Even though there is no motion, but there is a tendency of motion. It wants to move. It's not moving. The friction which stops it would be static friction. It's not would be, it is static friction. Now, whenever we talk about static friction, there are two things that you must understand because static friction is a force. Force is a vector. Every vector has two things. What are those two things every vector has?
Magnitude and direction.
Magnitude and direction. Let us first talk about the direction part because I can draw it here. What about the direction of static friction? What would be the direction of static friction? Anyone? What would be the direction of static friction? Direction of static friction would be such that it opposes the tendency of relative motion. When I say it opposes the tendency of relative motion, you can also understand it in this way. It will be opposite to the direction of tendency of relative motion. Do we understand the meaning? There is no relative motion happening, so I cannot say that it will be the opposite to the relative motion. It will be opposite to the tendency of relative motion. Now, let us go back to that example of inclined plane. The body wants to move down. It is not moving down. Something is stopping it. Static friction is stopping it. What will be the direction of static friction? Static friction is denoted by Fs. What would be the direction of static friction on the body which is kept on the incline? Example number 1, yes. What would be the direction of static friction on the body which is kept on the incline? I'm waiting for your answers. What would be the direction of static friction? In case number 1, the body kept on an inclined plane. The body is not moving, but it wants to move down. What would be the direction of static friction? Yes. Anyone? What would be the direction of static friction? Everything is right on your board, beta. What is the direction of static friction?
Right side.
What do you mean by right side? If this is down, then tell me what is right side. This is down. I'm talking about the inclined plane. Problem number 1. This is problem number 1, diagram number 1. This is the diagram I'm talking about. Can you tell me what is the direction of static friction on this body? It's a simple question. I will wait. It wants to move down. It is not moving down. Something is stopping it. Static friction is stopping it. What is the direction of static friction? I'll give you time. Think about it. I'll wait.
So the direction is upwards.
The direction would be upwards. Yes, it would be upwards. The body wants to move down. It is not moving down. Something is trying to pull it down. It is not moving down. Something must stop it from going down. That means that thing must be upwards. So the direction of static friction Fs would be upwards here, the green one. The direction of static friction would be upwards. Let us move on to the diagram number 2. Again, I am applying a force on the body. The body wants to move. Body is not moving. Something is stopping it. Static friction is stopping it. What is the direction of static friction?
Left side.
On this body, it has to be left, sir. As simple as that. It wants to move towards right. It is not moving. Something is stopping it. Static friction is stopping it. It has to be left. So this is how we determine the direction of static friction. Do we understand this? Yes or no? Okay, now comes the next part, and which is the most interesting part of this static friction, the magnitude of static friction. And remember this is a very important part that you must remember. Direction we have understood. What about the magnitude of static friction? The magnitude of static friction, and which is the most important aspect, is not constant. The magnitude of static friction is not constant, and it is a very important point. The magnitude of static friction is not constant, and remember it. The magnitude is not constant. It varies from, can vary from 0 to a maximum value. The value of static friction is not constant. I call static friction as intelligent friction. Why do I call it intelligent? I will tell you. The magnitude of static friction is not constant. It varies from 0 to a maximum value. The maximum value of static friction is constant. Maximum value of static friction is constant. The maximum value is constant. So it can vary from 0 to a maximum. That maximum value is fixed. And that maximum value is known as the next big term coming, limiting friction. So whenever we talk about static friction, this word limiting friction comes. The maximum value of static friction is constant. That is known as your limiting friction. The value of limiting friction is equal to mu s multiplied by n. Where what is mu s? Mu s is known as what?
Coefficient of static friction.
Coefficient of static friction. Coefficient of static friction. The value of mu s depends on the the bodies which are in contact. You can only change mu s by changing the bodies. This mu s is same as your mu k. Do we understand this? Mu s depends on contact surfaces. And this value of mu s is always greater than mu k. And that is why we say static friction is greater than kinetic friction. Are you getting my everything, bacha? The normal saying is that the static friction is more than kinetic friction. Why do we say that? Because the value of mu s, coefficient of static friction, is more than the value of mu k. It takes a lot of effort to start the motion of something. It will take a lot of effort. But once the motion starts, it becomes simpler compared to starting the motion. If something is stopped, if a car, you can see it. If a car is not starting and it is at rest, it will take a lot of effort to start the motion of the car. But once the car starts to move, it is easier to push it. Static friction is more than kinetic friction. Do we understand this? Now, coming back to your static friction, I call static friction as smart friction. S for static, S for smart. Static friction is smart friction. Why do I call it smart? Because it can change both its magnitude and direction, and we will see it. Static friction is very smart. It can change its magnitude, it can change its direction. What is the value of static friction? As I said, value of static friction is not constant, but I can give you an equation which from where you can understand 0 is less than or equal to Fs, which is less than or equal to Fl. And remember, the value of this Fl is constant. How much is the value of this Fl? Mu s into n. Do we understand this? Value of static friction will lie between 0 to Fl. And the value of Fl is mu s into n. So you can say static friction lies between 0 to mu s into n. And it is smart friction. Why it is smart friction? Because it can change its magnitude, it can change its direction. Do we understand this? Do we understand this? Have you written this, everyone? Now let us try to understand it with some questions. I have a body of mass m kept on a rough floor. I apply a force of 5 Newton on this body. But the floor is very rough and the body is very heavy. The body remains at rest. It does not move. Now, let me ask you the first question. Why is the body not moving? Someone must be stopping it. Who is stopping it? Who is stopping this body from moving? Who is stopping this body from moving?
Static friction.
Great. Static friction is stopping the body from moving. Now tell me, what will be the direction of static friction? What would be the direction?
Left side.
The direction of static friction would be left side. Well done. So far, so good. We are moving correctly. The direction of static friction is left side. Now, the next question is, what is the magnitude of static friction? Remember, the body is at rest. Body is not moving. What is the magnitude of static friction? The body should not move. Please apply your brains and you will get the answer. The answer is right there on the board. What is the value of static friction? The body is not moving. I am applying a force of 5 newtons. The body is not moving. Something is stopping it. Static friction is stopping it. What is the value? Think the answer is on the board. You can see it.
Sir, can you repeat the question again?
What is the value of static friction? You have told me the direction is left. Correct. Now tell me the value, magnitude.
Zero, sir.
If it is 0, body will move. There is nothing stopping it. Apply common sense, not physics. You don't have to apply physics here. You just have to apply common sense. If a force of 5 Newton is applied on one side, but the body does not move. So there must be a force in the opposite side, which is static friction. What is the value of static friction? Is it so difficult to you to understand? Think. You've done this problem 100 times now. 15 classes in Newton laws of motion, we have been doing this. It's not zero, because if it is zero, body will move. If it is zero, surface is smooth, it will move. No one is stopping it from moving it then. The answer is right there on your screen. Look at it. Universe is beautiful. Close your eyes. You will see the answer right in front of your eyes.
Five, sir.
It is 5, sir. Why you have taken 1500 minutes to do this? It is 5 Newton. 5 Newton is trying to pull it forward. It is not moving, so 5 Newton has to be backward. There's no physics involved. Good. Now, in order to move this body, I start increasing my force. Same scenario. I increase my force to 10 newtons. But the body still remains at rest. Body does not move. Who is stopping it?
Static friction.
What is the direction of static friction?
Left.
What is the magnitude of static friction?
10 newtons.
So you see, it is smart. It is smart. Look at the smartness. Here it was 5. Here it is 10. It can adjust its magnitude. Smart friction. It's smarter than us, at least. He knows how much value I should apply so that I don't move. I increase the force to 15 newtons. The body still remains at rest. What is the magnitude and the direction of static friction?
Direction left.
And the magnitude?
15.
See? It is smart. It has changed its magnitude. I repeat the same experiment. But now I apply a force 5 Newton here. The body still does not move. What is the magnitude and direction of static friction?
Direction is right, magnitude is 5.
See? Smart friction. Smarter than us. He now knows that the force is on the left, so I'll have to be on the right. Smart friction. It can change its magnitude. It can change its direction. One more last example. Apply a force of 10 newtons. Still remains at rest. What is the magnitude and direction of static friction?
Direction right. Static friction. Magnitude 10.
See, smart friction. We are also getting smarter with this smart friction. If you stay in touch with smart people, you are going to get smart. Static friction is smart. If you understand this smart friction, we become smarter as well. Do we understand this? But you must realize that this static friction is not going to increase always. At some point, it is going to reach its maximum value. Do we understand this? That maximum value is known as limiting friction. Do we understand this? So if I want to move this body, the force applied must be more than limiting friction. Otherwise, the body will not move. Do we understand this? Yes or no? No or yes? Huh? That is what you need to understand. To move a body, to start the motion, force applied, whosoever is applying the force should be greater than FL. Otherwise, or just equal to maybe. When it is just equal to, the motion will just start. Just start. Do we understand it? Or this is gone about I think why sir? This is enough. Done. Done. Do we understand this? Huh? Now let me frame a question for you. This is a body of 5 kg. The value of static friction, mu s, is 0.3. I apply a force of 5 Newton on the body. The first question is, find out the value of FL. Number 2, does the body move? Number 3, if the body does not move, then the friction would be static. Find out the value of static friction. And the question passes on to you, my dear friends. I'll give you 1 minute to solve it. Are we solving the problem, bacha? Yes or no? No, yes. Huh? Do I have anything that looks like an answer? Anyone with anything that looks like an answer? The first answer, anyone? What is the value of limiting friction? Anyone got the answer for this? Anyone has the answer, yes or no? Okay. So how do I get the value of limiting friction? I draw the free body diagram. This is 50 newtons. This is N. Looking at this blue equation, I can find out the value of N. Look at this blue equation. We have done it 1500 times. The value of N would be equal to 50. That is your normal reaction N. The value of N is 50. Now we must remember what is FL, limiting friction. The value of limiting friction is mu s into n. So now I multiply mu s by n. Mu s is 0.3. I multiply it by 50. I end up with 15 newtons. So remember, my value of limiting friction is 15 newtons. Friction can go up till 15 newtons. Now I look at the diagram. I've applied a force of 5 Newton onto it. Can you give me the second answer? Does the body move? Can the body move? Yes or no? The applied force is 5 newtons. I have found out the value of limiting friction as 15 newtons. Can the body move?
Yes, sir.
The body cannot move because the applied force 5 newton is very less compared to 15 newtons. So the body cannot move. The body cannot move because the applied force is less than your limiting friction. Now, the third question is, what is the value of static friction in this case? As you understand, the body does not move. The body now remains at rest. Can you now tell me what is the value of static friction? What is the value of static friction?
5, sir.
The value of static friction would be 5 newtons. Very nicely said. And it is less than the limiting friction. So the body, because the applied force was less than the limiting friction, body could not move, and hence the body remains at rest. Do you understand this? Do you understand this, everyone? Okay, please note it down and I'll give you one more problem on this. Everyone understood this? I hope that you can solve this problem. Have you noted it down, bacha? Have you noted it down, everyone? This is the next problem. And the condition is given. You have to find out, number one, the value of friction. Value of friction. It is not given whether the friction is static or kinetic. So you have to find out the value of friction force. Number two, you have to find out the acceleration of the body. I'll give you 1 minute to do this. Anyone got the answer? Okay, shall I do it? Okay, so how are we supposed to do this? We need to draw the free body diagram. This is 20. This is normal reaction N. We can find out the value of normal reaction. The value of normal reaction that is going to come. How much will be normal reaction? Anyone?
20.
Normal reaction is going to be 20 newtons. Now the value of Fs is given to us. So let us find out the value of Fl. What is the value of Fl that you are going to get? The limiting friction is mu s into n. What is the value of limiting friction that you are getting?
10.
It is 10 newtons. Now answer, is the body going to move? That question was not asked, but we have to ask ourselves, is the body going to move?
No.
Body cannot move because limiting friction is coming as 10 newtons, but the force applied is only 8 newtons. So the body cannot move. Do you understand this? If the body cannot move, then what is the acceleration of the body? The body cannot move. What is the acceleration of the body? No one knows it? Body is not moving. So what is the acceleration?
0, sir.
0, sir. So why you take so much time to do this? The acceleration is 0. The body cannot move. Now the next question is, what is the value of the frictional force? Can now you quickly tell me what is the value of frictional force? What is the value of frictional force, beta?
20, sir.
The value of friction force is 8 newtons. It has to be equal to the applied force. We have seen it. The body does not move. Acceleration is 0. Frictional force would be same as the applied force. It will be backwards. And the value is 8 newtons. Please note it down. I hope you have understood this. Note it down, please. Everyone has understood this? Please remember this, beta. Have you noted down? Chalo, then we move on to the last part of this chapter, and this is this diagram. This is the graph between applied force and your frictional force. Graph between force applied and friction for a body which is kept on a horizontal surface, which is the question that we were solving. Now, how does this vary? As you can see, when the force is 0, the body will not move. Do we understand this? If the floor is rough, the body will not move. And up till this point, when the friction reaches its limiting value, the body cannot move. Do we understand this? At this position, the value of friction becomes F limiting, and that becomes equal to mu s into n. Your static friction will not allow the body to move. And in this region, the green region, the body cannot move. Do we understand this? Yes or no? So in this green region, the body is stationary. I hope everyone understands this. Body is stationary or static. In this green region, the friction is static friction. Do we understand this? This friction is static friction. Also, the value of this static friction Fs will be equal to the applied force. Do we understand this? Yes or no? Yes or no? And this angle theta, which this line makes, this angle theta, because both the forces are equal, so this is y is equal to mx plus c. The value of this angle theta is 45 degrees. Do we understand this? Remember these points. Now after this green zone, the green zone ends here. After this green zone, friction dips a bit and then it reaches its kinetic range. Here the friction is kinetic range, which is equal to mu k into n, and the body is moving. So in this pink zone, the body is moving. Do we understand this? Motion starts, body is moving. In this pink zone, what is the friction which is acting on the body? Tell me, which friction is acting on the body? Static or kinetic? The friction which is acting on the body is kinetic friction. What is the value of this kinetic friction? The value of this kinetic friction is mu k into n. And remember, this kinetic friction is less than the limiting friction. Remember, important point, the value of this mu k is less than mu s. You must remember static friction or kinetic friction is less than static friction or limiting friction. Do we understand this, everyone? This is the diagram that you must remember. Two different zones. One is the static zone, static friction coming in there. One is the kinetic zone, kinetic friction coming in there. The applied force is less than your static friction. Body cannot move. Body can only move when the force becomes more than your kinetic, more than your limiting friction. Do we understand this?
Yes, sir.
With this, we come to an end of this chapter, which is static friction. We don't normally expect a question from this chapter. If the question comes, it would be a theoretical question, whether based on this concept of kinetic friction or static friction, or based on this graph. Very rarely you might get a numerical. Very rarely you might get a numerical, but I hope if you get it, you should be able to solve it. Remember, limiting friction is the maximum value of static friction. The value of limiting friction is mu s into n. Do we understand this, everyone?
Yes, sir.
With this, we come to an end of this chapter. In the next class, we'll begin our journey with a new chapter, work, power, and energy. Take care. God bless all of you. Bye-bye.